Hi everyone, my name is Mathew. I'm an Android developer, and the topic that we are discussing today is mobile app development, a journey through Android and key insights. So although we will discuss general topics related to mobile app development, this mainly will be related to Android app development. So a bit about me, I have 12 years of experience in mobile app development, and I specialize in native Android app development, which I will explain what is native Android development is. And I have built around 10 plus small to large scale apps. And some of the apps I have been part of development has around 1 million to 5 million downloads. And I have developed few small apps in React Native and have a basic understanding about how to develop an iOS app. And I have experience working in small to large scale companies. So I started my career in a small company, then moved to a medium sized company. Now I'm working for Lloyd's Banking Group. I moved to UK before 1.5 years, and before that I was working mainly for one company based in US. So most of the apps I have developed were for US-based companies. And some of the apps are there on Play Store, and some are not there. Some are enterprise apps, which were only distributed to the employees within an organization. Sorry. So how I started app development? Okay. So I have started Android application development as part of my final year project back in 2011. So I was like giving different proposals, like in .NET, JSP, PHP, and all were getting rejected. Mainly because there were already like many other projects done by our seniors. So they were looking for something new. So I started searching what's new. Then this mobile app development came to my mind, and then I had discussions with a few of my seniors. Then I found out that okay, Android was becoming popular at that time. I think it was around 1.6 version of Android and 2.3 that phase during 2010, 2011 time. So I found it much easier because for Android, I needed to only know Java mainly and a little bit of XML. So I knew Java a little bit, and also like all we needed was one Windows machine. But for iOS, when I checked, I needed Mac. At that time, it was not affordable for me as a student at that time to buy a Mac. So I started Android development. The IDE at that time, which I used, was Eclipse, and Java was the programming language, and with the Android SDK. So that's how I started. So I submitted one proposal. They accepted it. Then it was a 1 year long project. From that time onwards, I have been an Android developer. So the journey started in 2011. And this is how the Eclipse IDE looked at that time, during that 2010, that time period. It was not bad, but it was not that great too, but it kind of served the purpose. And emulators, trust me, this was really slow. You require a lot of patience. Sometimes it was taking around 20 minutes, 30 minutes. Even you could go for a walk after turning it on. And sometimes this emulator is stuck forever on this Android splash screen. And if you don't know why we need an emulator, so generally we develop Android apps and we test it on a physical device or on emulators. But this was not a huge problem for me because something else had taught me a lot of patience before this, the dial-up connections. I think those who are born in 90s or before that might remember this. And you can see some crazy numbers like 39 years, 3.6 KB download speed. Any of you used this dial-up connection? All right. All right. So the most frustrating part with this was when you try to download your favorite ringtone or song or your game, it reaches around 99 or 98%, and the connection breaks, and you have to start from the beginning. So that was really frustrating. So compared to that, this was nothing. So these were some of the popular Android devices at that time. This is Samsung Galaxy S2. And there were a lot of devices made by HTC. And this was one of my favorite devices at that time, released by Micromax. I still remember me checking all the videos of this phone because I wanted to buy that phone. So that's one of my favorite phone at that time. And talking about mobile app development, we can generally divide that into two: native mobile app development and hybrid mobile app development. There's a third type called web app development, which we are not discussing today. So let's limit our discussion to these two, like the native mobile app and hybrid mobile app. So what's native mobile app development? This is the definition: the process of creating mobile applications that are specifically designed and built to run on a particular mobile operating system using the platform's official tools and programming languages. So that's the definition. So I will try to make it simple. Let's say we are developing an iOS application. That means for Apple devices. And we are using Swift or Objective-C as the programming language. And we are using Xcode as our IDE. And we are developing an app using this. Then we can say that that's a native mobile app development. Okay. To be more specific, that's a native iOS app development. Okay. And if you're using Kotlin or Java and you're using Android Studio as the IDE for creating apps for Android devices, then we can say that also as a native mobile app development. To be more specific, native Android app development. So the main benefits of native mobile app development: superior performance, enhanced user experience, full access to device features, reliable updates and compatibility, scalability, and the one drawback is that the separation of, separate code base. For example, if you need to develop an app for iOS and Android, generally we will have to maintain two separate code bases. There will be one team working on Android, one team working on iOS, and they will have to maintain separate code bases. There should be separate QEs, separate release cycles and everything. So this is one of the major drawbacks with the native apps, but native apps are really powerful. And hybrid apps. As the name suggests, the core idea behind hybrid mobile app is to have a single code base. And from that, we can create both iOS and Android Android apps. So generally, the core concept is to have a single team that can develop these apps, and there will be QEs for testing both these iOS and Android apps. And like the benefits, single code base, less development time, less developers. And the drawback that I have seen in my past experience is the scalability. It means this heavily relies on a lot of packages. The more and more the app becomes complex, you end up adding more and more packages. And some of these packages may work in iOS that may not work in Android, and vice versa. So although the original idea is to have a single team or a single developer developing both iOS and Android, finally you will end up having one iOS engineer, one Android engineer, and one hybrid engineer. So that generally happens if you try to scale there. But these technologies are becoming more and more, better. I think in few years, this will, some of the statements I make now may not be, relevant at that time. So if you like to go in that route, these are the options, like React Native, a really good option. Flutter, you can consider. And there is also something called in multi-platform, which you can check what exactly is that. I haven't used that personally, but I have used React Native. And the major drawback, and also finally, the idea is to have a single developer, but finally we'll end up having, asking for the support of a native engineer or the same team learning both the development of native development also, because sometimes we need to create native code and bridge that with the hybrid code for some of the features to work. And also, as we add more and more features, it can become more and more complex, the code base. And the native versus hybrid, this is like a, debate that has been going on for a while. So when to choose native and when to choose hybrid. So some of these guidelines, may not be true in coming years, but right now, these are the general rules. Like, if the application is bigger and has a lot of features, then it's better to go with native. And if you are expecting a lot of changes in future, then native is the best solution. And if you have adequate budget, need to utilize latest OS features, then in those cases, native is the best. For example, a banking application, okay, or an application that needs to communicate with multiple sensors, or an application that need to do a lot of background operations, like uploading videos, audios, a lot of heavy tasks, and you don't know what the future of that application is. You're planning to do a lot of, planning to add a lot of features into that. So in that case, it's always better to go for native applications. And the hybrid, best for small to medium-sized apps, no plans to add complex features, and need to release both iOS and Android apps quickly. And if you only have limited budget, and ready to wait until wrappers are released. So what this wrappers is, generally in case of React Native, what they do is that when Android and iOS team release the main code or APIs, they put a kind of a wrapper on top of that, and they publish that to the developers who are using this React Native or Flutter. So we may have to wait until that's ready. So we may not be able to quickly use the latest features, provided by the OS. So that's one drawback. But let's say if you need we only need a small application, like for booking a hotel, or maybe for reading the content of a book. Reading all the books in a library or such kind of small application. Then best option is to go with the hybrid, because in that case, you can quickly develop both iOS and Android applications. And let's start with the discussion of Android. So by saying about Android, we will be discussing only the native Android app development. Okay. So the first commercial version was released in 2008, and now this is not an accurate number, but Android powers more than 2 billion active devices worldwide. Okay. And you can see some of the powerful devices like Samsung S24 Ultra and Pixel devices here. And also the latest Android version is 15. Okay, when I started, it was 1.6, 2.3. That was the version. Now it's Android 15, and Android 16 will be released next year, or I think this year. I'm not sure. And if you are interested in starting Android app development, you need these three things. Like one, Android Studio. It's the IDE, and then basic understanding of Kotlin. That's the programming language, and an understanding of Jetpack Compose. So I will explain what Jetpack Compose is. Okay. And Android Studio. As I said previously, when I started development, it was Eclipse IDE that was used for Android app development. But later, Android Studio became the official IDE for Android app development. Okay. This powerful IDE. Initially it had a lot of problems, like a lot of errors, and it was unstable. And if you check in Stack Overflow, you can see variety of errors posted by different developers complaining about different problems. And whatever error you put in Google, there will be 5 or 6 people with the same problem. Okay, that was the condition. But now it has become much stable, and the emulators in this Android Studio now boots up within 5 to 6 seconds. It's super fast. Everything is much fluid. And this has inbuilt support of this Gemini tool and everything. So right now, this is really in a good position. If you're starting Android development, this is really a nice time to start, because due to the stability of this IDE. And Kotlin. Okay. Previously, Android was, for Android development, we were using Java. But back in 2019, Google adopted Kotlin first approach. Okay. Although even now we can use Java for Android app development, they give priority to Kotlin. Okay, so everyone is moving to Kotlin now. So even some of the legacy code, they are moving that to Kotlin side by side. The beauty is that both Java and Kotlin can work together in Android. So let's say if you only know Java, you can still start development, and then you can slowly move to Kotlin. Both can work together. So there are many apps there, bigger apps, in which new code is written in Kotlin, whereas the old code is already there in Java. It's concise, null safety, can work with Java. Okay. What is null safety? I think that's one of the core benefits that I see with the Kotlin, because previously with the Java, one of the major problem was this null pointer exceptions. Like whenever we see a crash, the top crash usually is null pointer exception. Okay, with the Java. But with this thing, it's really difficult to create that error. If we as developers have to try it so hard to make that error, intentionally or something. But normally this, Kotlin reduces this this null pointer exception to a large extent. And here is an example of the difference. You can see the Java code here of a class. The same is written in Kotlin here. The number of lines are really less, and then you get all the functionalities that are written there in Java with this much number of lines. Okay, that's the difference. So I'm not saying that Java is bad, but this is a much better version, okay, of that. If you're starting Android development. And what's Jetpack Compose? Okay, so when I started Android development, at that time we used to write all the logics, the core logics in Java classes, and the UI was created using XML. So there were XML files kept separately. And then the core code, the functions, classes, everything was written on Java. And there was a reference of this XML, added within Java file, and then used to control everything from the Java. So right now, we don't need to learn XML, although there are many developers using XML now, even now. But with Jetpack Compose, you only need to know Kotlin, because you can write the UI in Kotlin directly as a function. So this like introduced as a replacement for XML, fully declarative UI toolkit allows to define the UI components directly in Kotlin code using composable functions. Okay, and here's an example. So this is the old one. You can see the XML here. It's written in XML and then it's showing text view and a button. Okay, that's how we add a text view and a button here. Okay, using XML, and that is kept in a separate file in XML, and then we make connection to our Java classes or Kotlin, and then we control the UI from that. Okay, that's how it used to work previously. But now we can directly write it as a function. You can see that it's written as a function, fun, my app. Within that, I'm adding a column and adding a text, and I'm adding a button. So this will result in the exact same UI. That we built using the XML. Okay. So the effect is same, and then you don't have to learn all these things. I mean, there were many things like linear layout, relative layout, frame layout. There were a lot of kinds of layouts were there in XML, but now it's much more simple. Like there are columns, rows. There's something called lazy column for showing the list, lazy row. There are a lot of things available within Compose. Only thing is that you need to add one annotation at the top called @composable. With that, we can create class much easier. And the best thing here is that you can create some dummy components, like a component that can accept any text or like text color, background, and then we can customize in any way we want. So we just define the skeleton, and we can reuse that component in multiple places. So what we generally do is that we make small pieces and keep that in a common area, so that could be reused in all the classes, and then we can pass whatever parameters we want there. So this is really powerful, Jetpack Compose. Initially, I found it a little bit difficult to fully understand, but based on my understanding in React Native, I found it much easier. So for someone who has been using XML for a long time, may find it a little bit difficult, but once you start using, you won't even think about going back to XML. And if you are interested in starting Android app development, there's a course on the developer site of Android. It's a simple course, both for beginners as well as for experienced developers. Okay, so it's a well-structured course. It will take you to there are like 5 or 6 steps. So by the end of that course, by the end of all the steps, you will have developed a small application, Android application. So there are courses for both beginners as well as for experienced developers. And advancing beyond beginner level. Okay. So let's say you start Android development, you experimented with it, and then you added different things. You create a small application, and after this stage, maybe that may happen after 6 months or 1 year or 2 years. Doesn't matter. Okay, but after this, it's important that you move to the next phase. Okay, next level, because for me also at the initial stage of my career, I also faced a similar problem. Sticking to certain methods which I learned during my college days, and not moving to the next level, or not using a lot of architectures, principles, or everything. So first thing is that they apply different architectures. There are architectures like MVI, MVVM, and then we can use a combination of both these. There are different architectures available. So use that what's best for you or your team. Okay. Then embrace coding principles like solid principles. Then try and everything, and try to make small classes, functions, and everything. And then unit test. Okay, as developers, I know that it's we all are kind of hesitant to write unit test. We just want to finish a feature, and then we are not that interested in writing unit test. But this is really important. Try to make sure that we write unit test with 100% code coverage, at least for the core logic. Okay, not for the entire app. At least where you're controlling adding the core logic. So that's really important. And there are like unit tests. If you have enough time, then do unit tests also important. There are libraries like Expresso or Roboelectric for this purpose. But if you don't have enough time, I'm not asking you to do the UI test, but we should do the unit test, and then we can set up a pipeline and automate all the checks. Okay, whenever we are pushing some changes. And multi-module structure. So when we create an Android application, we by default it opens only a single module. Okay, so we generally add different packages within a single module. But once we cross that level, we should experiment with the multi-module architecture. So it's like one module can be for one feature, and another module can be for another feature. So everything should should be able to work independently. Okay, we should be able to take one piece out and put one piece in. Okay, so the basic idea behind that is this. So just try and see, what you can find out about this multimodal architecture and move towards that, after the initial learning phase. And then dependency injection, really powerful. So when I started development, I was like, if I have a class A, I used to create the object of that, the instance of that A everywhere. Like, let's say everywhere I was just, creating a new instance of that everywhere. Now imagine that we have a library for an API call, or we have an instance of a DB. So it's not a good practice to make the instance of this DB object everywhere, everywhere we are using. So dependency injection actually provides a centralized location where we can create all the objects and then supply it or kind of inject it wherever we want. That's, I think, why then they gave the name dependency injection. So let's say, and we can also tell it whether to create, a single instance or multiple instances. Okay, let's say we have a database class. Okay, we need to make sure that a single instance of that class is created. Then, using dependency injection library such as HILT, we can mark on top of it saying that, okay, it should be a single instance only. So for the entire app, a single instance of that database class object will be created. So, and also if we have added enough, proper coding principle architecture, we can always remove that particular part and then put something else. For example, let's say I'm using a library for API calls, and after 1 or 2 years, I feel like, okay, I don't want to use this library anymore, I want to use something else, then I should be able to easily remove that part and put a new library there without affecting other sections of the app. Okay, so that's why we need to follow the architecture, the coding principles and everything, and also dependency injection really important. Okay, and offline functionalities we should provide. Then security, like if you're storing any of the user data, then we should properly encrypt it and try to avoid storing any sensitive data there. And background operations we should learn, and work managers. So this work manager thing is really powerful. Like, let's say previously, when Android started, whenever we want to do a heavy task, we used to do that immediately. Okay, let's say if I want to upload a large video to server. So previously, during 2015-16 time, what we used to do is that we directly upload that video. Okay, then people started to become more conscious about the battery, the performance. So with Work Manager, the benefit is that you can define a job and you can set some criteria. Like, you can tell device to trigger this particular job only when certain conditions are met. For example, when battery is charging, or when our device is connected to a Wi-Fi. So the thing is that, let's say my phone is connected to mobile data. I'm trying to upload a video. Okay, so that will not happen immediately. It will wait until the device gets connected to an unmetered network like Wi-Fi. So then only that upload will start. So we are defining a job, we are setting some criteria, and we are putting it there. And then whenever that criteria is met, it automatically happens. Okay, so this Work Manager is really important. And then explore features offered by Kotlin, because there are a lot of nice functions provided by Kotlin which can reduce a lot of codes. Code that we write from scratch. We have to reinvent a lot of things. It has a lot of powerful functions available. So I even don't know many of the functions that Kotlin is having. So it's I learned that when I do code reviews, or when others are suggesting me to use that, or sometimes I use ChatGPT. I write a code and I ask it, okay, is this the optimized version of this? Then sometimes that suggests me some, a better version of Kotlin. Okay, but the problem with using ChatGPT is that if you are a beginner, don't copy code from ChatGPT. Use it only as an assistant. Write your own code, put it there, and ask it to optimize the code. And before you copy it, you make sure that you fully understand the code. So even if you're copying an entire class, you should make sure that you fully understand. Okay, make sure it's your assistant. Okay, don't give it control. The control should be with you, but you should understand what you're doing. Otherwise, if, let's say, you may be able to complete an app, but if some issue happens, then the debugging will be really difficult at that time. And publishing Android app, for that you need an account in Google Play. It's just a one-time payment you need to make. That's just $25. Once you make that payment, then you can upload your apps into the Play Store. and from the Play Store we can control in which region of the world it should be available, our app. And then we can also see how many users have installed, which are OS versions they are using, and then what all crashes are there. So such details, general details it will provide. And sometimes it's not the guidelines or the rules are not as strict as in iOS. With Apple, it's much more stricter. But when it comes to Google, it's not that stricter. But I think that now they are making it much more stricter, compared to the previous. Previously, when we ask for permission, like a storage permission, we used to get access to the entire gallery. Okay. Now they have put more and more conditions, more and more, controls over it. So it's much more secure. So if you violate such things, then we may have to provide some, justification why we are doing like that and all. But compared to Apple, it's much easier. We can quickly release our app on Play Store. There are other ways to release. For example, let's say we develop one app. You can send it to any of your friends or relatives. Okay, you can just upload the APK. That's the build extension. Just upload it on Google Drive, and you can send the links to any of your friends or relatives. They can directly install it on their device. Only thing is that it will ask for it will show a warning saying that this build or app is unverified, and if they click continue, then it will get installed. So you don't even need this for testing in your with your friends or with your relatives. You can send it easily. Okay, and for that you don't need an account in Google Play, and this is just for publishing the apps. And there's a general perception that Android devices are slow. Okay, there are two aspects to this. Okay, one is the role of manufacturers, the device manufacturers, and another is the role of developers. Okay, so whenever I talk to some people, they say, okay, Android devices are slow as compared to iPhone, or they generally compare it to iOS devices. Okay, so this is like a common complaint or kind of a common perception that has been going on for a while. So the manufacturer's role. So there are over 1,300 brands are there, and 24,000 plus unique devices are there in market. Okay, Android devices. The devices range from 4 GB storage with 1 GB RAM to around 512 to 512 GB storage and 18 GB RAM. Okay, so there are a wide range of devices are there. And many of the OS manufacturers, the device manufacturers, what they do is that they take the stock version of Android and they add a lot of customization on top of it. For example, One UI by Samsung. So what they do is that they take the stock version of Android, they add certain features on top of it, and like Oxygen OS or Nothing OS. So there are different variants of Android. It's nothing, just they're taking the stock version, adding more features. And most of these companies are making it much better than the stock version. And if you take Pixel devices, Google's Pixel, there you can find the stock version of Android without much customization on top of it. But generally what others do is that they simply add more and more features on top of it and publish it. Okay, some of this customization may be good, some may be bad, and the general thing is that may usually take some time. That's why it's, when you purchase devices from a manufacturer other than Google, generally it takes time to receive updates. The reason is that they are customizing and making changes on top of the stock Android version. So they are doing all this testing and everything, and then they release it to their customers. That's why even sometimes in Pixel you get the latest Android version quickly, but when it comes to other devices, it may be a bit slow compared to the Pixel device, and that's the reason. And why I said device manufacturers role. First of all, this sort of device ranges are there. Okay, there are low spec devices to high spec devices are there, and then developers role. Okay, and this is a bit an exaggerated example. Okay, so imagine that we are shifting house. Okay, and we try to do this. Okay, put all our luggages on top of SUV. Okay, imagine that this is a decent SUV and with a good engine, and it is not that bad, but we try to do this, okay, like putting all those things there and try to, move to our new house. Now, this may work, okay, if we drive by putting our car in first gear, and if we are going slowly, this might work, okay. But imagine that in place of this, this is like an old car, okay. maybe an old car or car without a powerful engine. That car may not even move, or that car may totally break, or the engine may get damaged or something. But in this case, although this can fulfill the purpose, there may be some long-term impacts. We don't know, okay? But for now, it will work if you put in first gear and if you move slowly, okay? So the main thing here with the manufacturers is that they make all these customizations, a lot of heavy changes, and they publish it to some low-end devices, and then that generally makes these devices much more slower. Okay, that device may not be able to handle that much customizations. Okay, then people generally complain that okay, device is slow. That's one part. Okay, and second, this is a developer's role where they add too much load to the app. So why is it too much load? Okay, just keep this example in mind. Okay, this is really important. We'll come back to this. So in Android, there are two kinds of thread. One is called main thread. It's also known as UI thread. And we can say everything as background or worker thread. Okay, there are many things, so I'm not getting into the details. And what a main thread is, let's say you are opening an app, you're seeing the UI. So it's the main thread which is actually responsible for displaying this UI. And when you tap on a button or when you swipe on a screen, it's this main thread that making it happen. All the nice animation and everything happening, it's due to this main thread. Okay, this main thread is powerful, but the problem is that if you keep it busy, if you add too much load onto the main thread, the problem is that the UI will become like, UI won't be smooth. Okay, the navigations will be really slow, and you can see it moving from one screen to another. And then and also the problems like the device may overheat and battery may drain quickly. So such problems will happen. So it's really important to keep this main thread as free as possible and only for UI related things, okay? And use the background, and also like there's the background threads. Okay, why background threads? We usually put this complex or intensive tasks. For example, let's say, we are doing some heavy calculations, okay, or doing some database operations that we can do in our background thread, okay, or we are communicating with a sensor, okay, like we are reading the sensor data periodically. Such things can happen in background thread. Or imagine that we are trying to upload a heavy video to server. That can happen in background thread. But imagine if we try to do that on the main thread, okay, that will block the entire UI, and the entire UI will become slow, okay. So this picture is actually equivalent to developers putting too much load on the main thread. Okay, so with latest devices, this will somehow work. Okay, let's say we are using a powerful device. Even if we put too much pressure on the main thread, this will somehow work. Okay, with the new devices or high-end devices. But if our device is like is not having a powerful hardware, then this may not work. And I have seen instances where the entire app crashes, or the device even restarting because the device is not able to handle that much pressure on the memory. So such things can happen. And also like device could overheat and the battery could drain quickly. And even in high-end devices, like maybe with the Samsung S24 Ultra, even such devices, the battery draining will be much faster, if you do this, like if you put too much strain on the main thread. So the idea is to keep the main thread as free as possible, as fluid as possible, and do everything with the help of background threads. And once the task is complete, just inform main thread that, okay, this is done, this is completed, okay? So that will keep the main thread always, active or responsive to the user inputs, and then it will not cause all this, sluggish UI performance. So that should be taken care of by developers. And always what I suggest is to test our app on low-end devices, okay, not on high-end devices. Our app may work properly on Pixel or Samsung Ultra or any latest devices, but it's always better to, check. We need to check on high-end devices also, but we should also consider running our app on the low-end devices, and also devices with the low Android version, like 8.0, 9 or 10, something like that. Okay, not just on the Android 15, because there are many users who are still using Android devices with the Android OS version 10, 8, and all. So we should consider them also when we release an update or when we release an app. And this, okay, what's the best way? Like, instead of doing this, we can hire a vehicle which is built for moving heavy stuffs, okay? So this thing is actually equivalent to using background thread, okay? So you put our heavy stuffs into a vehicle, or in this case, a thread built for handling such heavy tasks, and then keep the UI thread, free. So let's say if you're removing all this thing from the top of this vehicle, then this vehicle can give its full performance, and it will increase the stability of this vehicle, and then the ride will be much more smoother, okay? And then everything can go on this vehicle, and the other luggages can, okay? So this is much better option. So always use background threads whenever possible, or whenever such complex or heavy tasks are there, and keep the UI thread as free as possible. Okay. Now the similarities between Swift and Kotlin. So let's say you learned Android, so you want to learn iOS also. It's not that difficult. Okay. So how we develop iOS is using a programming language called Swift. Okay, previously it was Objective-C, now it's Swift. Okay, now here you can see the similarities between Kotlin and Swift. Okay, in case of Kotlin, we are defining one var mutable variable, and it's here in Swift also it's using var, and for the other it's val, and it's using let for immutable, and nullable types it's almost same, and for function Kotlin uses one keyword called fun, whereas Swift uses func, F-U-N-C, and loops almost similar, and classes almost similar, and then if-else similar. So if you learn either Swift or Kotlin, it's not that difficult. I'm not saying that it's easy, but it's not that difficult to switch to iOS. All you need is enough time to spend for, and a proper project to work on iOS. Because generally what I have seen is that whenever I start doing something on iOS, I get pulled back to Android projects again. So that's the only thing. So, but if you have enough time, it's not that difficult. The concepts are almost same. And I think in iOS, there's something called Swift UI. I think that's similar to this Compose, Jetpack Compose. But I haven't used it personally, but that's my understanding. So if you learn Android, you won't be stuck there in Android forever. You always have an option to move to iOS. And the key factors for a successful mobile app. Okay. First, the UI. The main thing, don't clutter the UI with too much details. Okay. I think many of you might remember the Yahoo search. Okay. So the Yahoo search had the search bar was really small, somewhere at the top or one corner, and they used to have lot of ads and lot of other Yahoo Weather, lot of options embedded into that page, and it took a lot of time to load that page, especially with this dial-up connections. Even when you refresh that page, it used to take a lot of time. Then Google came, okay, with a cleaner UI, or with a simple search bar and with a white background. That's it. Then we all know that rest is history. Okay, so that's the importance of UI. So don't clutter UI by adding too much details. Keep it simple as possible. There are some nice examples, like I think Google Fit app. It has a really nice UI. So just try to take inspirations from such applications. And second, use colors that are easy on eyes. Third one, use suitable fonts. So when we consider a font, we should also consider the age group we are targeting. Okay, and provide dark mode support. This is one of my favorite point, because I generally use mobile phones during night time, and I always keep my Android Studio and everything in dark mode because I find it much easier on my eyes. So nowadays, almost all the apps are providing dark mode support. So when you are planning to develop an app, talk to your designer and also ask that designer to provide you the dark mode designs also, and implement that dark mode designs. And normally, we can enable dark mode automatically. That means when you enable dark mode on your device, our app should automatically change the theme to dark mode. And provide accessibility support. This is really important, because generally, some people may find it difficult to read certain small fonts. So what they generally do is that they go to settings of the device and they increase the font size. So at that time, our app should react to that. Our app should embrace that font size change. Our app's UI should not break. So basically, we need to test all this scenario, keeping the font small, font higher. Increasing the font size. All these scenarios we need to test before publishing an app. So that's really important. And also, Android provides an option called TalkBack for people who have problems with the vision. So what they can do is that once you enable something called TalkBack, it's a feature in Android. Wherever you touch on the app, the TalkBack will automatically analyze the content of that. For example, it's a text view or a button, and it will announce the content of that particular view. So we need to properly test that, make sure that it's working correctly. Okay. Normally it takes automatically. Let's say I added 2 text views on my screen and I enable talkback, and if I touch on any of the text view, it will announce the content of the text view so that people can understand what they are touching. Okay. And it will also announce that it's a button. Okay. So but sometimes we need to test. If we have a complex UI or something, we may have to test the accessibility part. So that's really important, so that we actually consider all kinds of users, all types of users and their need. So provide accessibility support, really important. And UX, use lightweight animations, don't use any heavy animations. Then don't block the entire UI, block it only if necessary, because the same thing, during the initial years of development, we used to show a big progress loader at on top of screen saying that, okay, please wait, or loading, okay? And we make user wait until that operation is done. Why developers generally do is because that's the easiest option, okay? You don't have to deal with any of the edge cases, because that's really easy. Once you block the entire screen, user will not be able to touch on any other parts of the screen. But do it only if it's necessary, like when you're deleting something or when you're logging out from an application. In such cases only do it, okay? In other cases, don't do it. If we can limit that loader to a small section within our screen, that's really good, so that users can still use other sections of our screen or other sections of our app. Let's say I'm trying to upload a huge video, okay? In that case, I don't want to block users until they complete uploading that video. It may take 5 or 10 minutes, okay? But what I can do is that I can hand over that task to a background thread, and then I can show the status somewhere saying that it's getting uploaded, or I can show the percentage, and I can still allow users to use other sections of the app, okay? So that's really important. That is going to take time. We may have to spend a lot of time developing and testing it, but that's really important, because that's what's going to make your app different from other apps. It's easy to show a simple loader at the top and block the entire UI, but it will take some time and effort to do the other thing. But the user experience will be totally different, when you do that. And utilize multi-threading, same we discussed, and consider the age group, target users age group. Let's say we are developing an app for Gen Z, a social media application. In that case, it's better to give a preference to gestures, okay? They may generally use app with their thumb or with one hand, okay? So in that case, we can develop our app by giving more preference to gestures. But let's say if we are developing app for elder people, in that case, it's better to add more buttons, enough descriptions, and then before they click on any of the button, we should provide enough details that, okay, this is secure, this is safe. We have to basically reassure them. So it's really important to consider the age group you are targeting. And if it's a mix of both, like younger and older generation, then it's better to keep that neutral, the overall UI and UX as neutral. And handle negative scenarios. The app should be able to handle negative scenarios. For example, when no connectivity, when net connection is slow, when server returns some error, low storage, configuration changes. There are a lot of things, okay? So we need to always make sure that these sort of scenarios are properly handled within our app. Sometimes what we do is that we generally check only the main things, when net connectivity is available or when it's not available. We simply turn on the Wi-Fi or turn on the net connection and check, okay, now it's showing an error. But we need to also consider cases like slow connection. So sometimes when users complain, we need to take it seriously and then see what's going on, okay? And our app should be able to handle this. So I'm not telling you to return like a error code from your server, okay? You can mock all this scenario within our Android Studio. We can keep local JSON files, and we can connect, we can consider that as our server response, and then we can mock all the scenarios, and we can see how our app behaves when such a scenario happens, okay? So make sure our app handles all such scenario gracefully. Our app should not crash if it's not getting a right, or if it's getting an unexpected error from a server. Our app shouldn't crash, okay? We should test all such scenarios, and our app should be ready to handle all such scenarios. And offline support, which is really important. Allow key features to work offline, then use local database. SQL is the database that used in Android internally, and use caching, then sync data seamlessly when online, reduce unnecessary cost to server. All this promotes sustainability. Okay, let's consider let's imagine that we are developing an app, okay, that's for doing a survey in some rural part of the world, okay, where net connectivity is not available. Now, imagine that I'm that person who is using the app. I'm going to different homes, and then I'm trying to enter all the survey details, and I click submit details. So as a part of survey, I'm taking few pictures, I'm recording few videos, I'm recording few audio and everything, okay. And if I click submit, at that time I won't be able to upload anything because there is no net connectivity available in that place, okay. So in such scenarios, what we should do is that we should make sure that all this data that we entered are safely and securely within our app, within our device, and I should be able to move and then add the next survey, okay. Let's say I completed 5 or 6 or 7 or 10 surveys, okay. Then I went back home, I connected my device to Wi-Fi. At that time, all the data that we added there should get uploaded to server. It should sync to server, okay. So we should securely able to store that data and provide that offline support. And whenever net connection comes, it should get synced properly, okay. Let's say if an error happens, it should auto retry at that time, or it should inform user that, okay, while trying to upload this data, an error happened. What would you like to do? Would you like to, retry or do something else, or do, take data in some other way from the app? So we always need to consider this offline scenario. And also imagine, this is also another issue. Another problem that developers used to. Another thing that developers used to do. Let's say I have one screen A. I'm navigating to screen B, and if I'm coming back to screen A, I'm calling the app used to usually call the API call again for populating all the data on screen A again. Okay. Imagine that you have around 1 million users. They are using the app, and then all these calls are going to server. Okay. The load on server will be high, the power consumptions, and also the mobile data usage. That also will affect, and also it will drain battery of mobile devices. So all those things can happen. So in that case, we need to utilize caching. Okay, whatever we can cache, if that's not like a sensitive data, we should cache it. Okay, and whenever we need to pull data, like that could be like done periodically, like every half hour or 1 hour or once in a day. That could be done using background thread. But whenever possible, try to provide an offline support, and also try to use caching. Don't always make API calls. Try to avoid as much as possible. But if that's necessary, do it. But in that case, our app should be able to handle negative scenarios. Then crash monitoring and bug tracking, really important. Let's say I release an app or an update, and app start crashing, and how I will know. Okay, generally we have a library called Firebase Crashlytics. There are many other libraries which you can add with your app. All you need to do is just add that library with your application. Okay. Then whenever a crash happens, you can see that on the dashboard. You can see how many crash-free users are there, how many users have installed. We can even see the function, class, and even the line number where this crash has happened. So based on that, we can fix that issue, and we can roll out updates. Okay. So adding that sort of a crash monitoring library, and then frequently monitoring crash after releasing a major update or a small update, or after releasing our app for the first time, that's really important. Okay. Then track analytics event is another important factor. Let's say we develop few features. Okay. We know that users are going to love it. How will we know users are using it or not? One way is to check our server, maybe for API calls, but there's a better way. We can add a library called Google Analytics Mixpanel or something like that, which will give you, all the data about the events. Let's say I have two buttons, button A and button B. I added an event for button A and another event for button B. And if after 10 days or something, I need to know which button user has clicked most, then I only need to track the event. Okay. So it's really simple. That library will handle all this, uploading all this, the uploading part of all these events and handling everything. We need not have to worry. All we need to do is just add that library and then trigger that event. That's it. So wherever we want, we can add the event, and then we can use that data to take future decisions. We can understand whether users are lacking it or not, or whether we should add any improvements. Let's imagine that we developed a nice feature. Okay, we think that that's users are gonna love it, but maybe after 1 month or 2 months, we are not seeing much usage, or users using that. Then that may be embedded deep inside the settings screen or more section. Then we can understand why that's happening. Okay, then we may need to move that particular option to our home screen, or somewhere much more visible to user. Or we can totally remove, totally stop working on that particular feature and work on something that users are loving. Okay, so such kind of data for that, this is really useful. The analytics events, you will get a lot of data from the dashboard, and then plan when to release. So this is really important. Let's say we have an app and there's a peak usage time. Let's say we develop an app for booking tickets, okay, and an event is happening tomorrow. Don't roll out any update today, okay, because that can cause crashes and then people will start writing negative reviews. So identify when the users are using the app most and plan major releases way ahead, okay, so that will give us enough time to fix all the issues that we see or identify using this crash monitoring, okay. So, and also try to, some of the apps which are heavily used during weekends, so try to avoid major releases during that time also. And encouraging app rating strategically, this is important. Ask people to rate your app, but do it only when you're confident, okay, only when you're sure that the app has, we have given a quality product there. And also ask them to review only after they complete one major task. Okay, like in case of WhatsApp, okay, maybe we are making a call. After that, they generally ask you what's your rating, okay, for this call, something like that, okay. So we shouldn't interrupt the core functionality. We should ask when users are generally free, or we should add certain conditions. Let's say user is clicking on a button around 10 times or 15 times, okay. So at that time, we can basically show that prompt and ask them to rate the application. Okay, so we need to identify when exactly, or we need to determine. We need to decide when exactly to show that particular option to. Ask them to review. Okay, and also even if you, let's say we have released a feature, we should know that there are no major crashes and users are loving it. And another strategy is to make it control from server. Okay, maybe let's say we turn on one flag in server, then it will the review prompt will start appearing for all the users. So such mechanisms could be put in place. And yeah, and also another thing, people generally don't install apps which are below 4-star rating. Okay, so this rating is really important. So we have to be really careful. And if users are saying that okay, they don't want to rate, they're clicking no, then don't annoy them. Don't keep asking them to rate. Okay, ask them only, like maybe we could ask after a month or 2 months or 3 months. Keep asking, maybe 2 or 3 times, but after that just stop asking. Otherwise, they may give a negative review. So it's all about timing. It's all about making sure that okay, there are no major crashes happening. People are loving the feature or our app. Then only ask for rating. Okay, otherwise it may backfire. And error handling, same. We shouldn't, if an error occurred, we shouldn't block the entire UI saying that an error has occurred. That shouldn't, whenever possible, try to avoid that. Okay, like if we can limit the error message to a certain area of the screen, like to a small portion, that's best option. And give a retry option there. Also add an option to automatic retry there. Don't block the entire UI due to a small error. Okay, don't show user that okay, an error occurred. Please try again, or whatever possible, whatever data we have in hand, display that data. Other areas, just show this error message or a retry option. So we are not blocking the entire screen. Okay, we are showing users whatever we have in hand, whatever data we have in hand, and we are only blocking a small portion of the app. Okay, so and also like it will take time and there will be a lot of edge cases, but I think it's important we do that also. And respond to customer feedback, user feedbacks on Play Store. Generally, people put negative reviews like, I hate this app, it's not working, it's not, I'm not able to log in, I'm not able to register. So instead of making fun of them, try to understand what's happening, okay? Try to reply, ask them to provide additional details. Because once I remember, we developed one app and users were complaining about they were not able to log in, okay? So we tried a lot, tried to find out what's happening, we couldn't find. Then one day, it was mainly for US-based customers, but we were working from a different region, different part of the world. But one day, what I have tried is that I woke up really early morning. I tried in the peak hour of the US time, okay, the traffic and the internet traffic time, okay. Then I got the exact same error. I was not able to log in. So instead of making fun of what and their complaints, then try to identify what's happening. Try to see is there any possibility of such a problem can happen, and also reply to them or respond to their comments, okay, and ask them for additional details. It's really important. And be the biggest critic of your own or our own product. This is the most important one because we have to be self-critical to improve our own product. We have to always think from the point of view of our users. We have to brainstorm with our team what improvements could be done, and we need to see what our competitors are doing, or at least provide them an equivalent feature, or provide something better than our competitors. It's really important. And postpone the release or of a major update of our app if we have to. Don't publish a half-baked product. Let's say we are working for a big company, a big brand, and if you release a bad app, then people will give poor rating that can even affect the brand name. Okay, this will have a lot of impact than we think. It's not just an app; it can damage the brand name, and it will have a lot of business impact. When you consider the business aspect. So we need to always consider from the user's point of view, and postpone the release if required, and also don't lose touch with your core users. Okay, always try to use the app, your own app. Then only you will understand. Okay, maybe use it when connected to Wi-Fi, when connected to mobile data, maybe during daytime, nighttime. So then you will start understanding more and more issues, and then we will get a better idea about our product. Because as developers, sometimes we think like this. We think that okay, we are drawing this thing, okay, and what really happens is this, okay. So we have to be careful before we release an update. That's important, but always try to think from the point of view of the users. Yep, that's all. Any questions?
Very much. We've got a question online. No, hang on. He's only put half of it in because there's a limit on how much you can put in.
All right.
Back to me. Has anyone got any questions?
All right.
You talked about accessibility, about font sizes and stuff like that, because the users can change the font size. I've done some Objective-C apps a long time ago. It's painful. I wouldn't suggest anybody use Objective-C at all. And I've done Maui and I regularly use Flutter. They all seem to struggle with being responsive. Through Jetpack Compose, do you get any responsive helpers or anything like that?
No, generally what happens is that we can only handle it to an extent, okay? Sometimes, we can support multi-lines, but even that, there's a limit for that, okay? If you increase that beyond a limit, then it will start showing this dot ellipses, three dots. But the thing is that whenever possible or to the maximum limit, we should support. But I have seen certain apps which don't respond to this device font changes. Okay, even if you change in device, the font sizes within the app remain fixed. Okay, that shouldn't happen. At the same time, even if you are changing the font size, it shouldn't break the app design. Okay, but it should gracefully handle. But we can only handle up to a certain limit, but handle it till then. For the rest of things, just it's up to us or our designers to whether to limit that to 2 lines or 3 lines, okay, or just show dot. So the idea is to just support as much as we can. So that also depends on the device, the width of the device. And also another thing is that if you are creating an app with the Jetpack Compose for fonts, that can directly run on tablets also without much changes. Because everything, if you're not hard coding anything, if you are giving full width or height and everything, it will automatically start working tablet without any major changes. You only may have to make 1% or 2% changes, and you don't need to make any drastic changes for the tablet. It will automatically start working in tablet. That's a good thing about Jetpack Compose. Even with XML you can do, but with the Jetpack Compose it's much more easy. But with the font size, we have a limitation with the hardware. So that we can't bypass, but the thing is that support it as much as possible and make sure that that's not going to break the UI. That's the only thing.
I've got the online question ready now. So Rob says, have you had any experience with Xamarin or Maui? We've done a few apps in Xamarin on both platforms, and I'm partway through a big Android-only Maui app. We're a C# house, otherwise I would have advocated for Kotlin. I wonder if you could compare them.
I don't have any experience working with the Xamarin. I only know a few friends who work in Xamarin. My I had limited experience only using React Native. But with the React Native itself, the only issue I found was, as the app was getting more and more complicated, the number of packages increases and the code became more and more complex. That's the only thing I found. So I generally go for native if the app is medium to large size, or if I'm thinking I'm planning to add more and more features in future. And if it's a small scale app where the scope is limited, we can generally go for any of the hybrid options. But to answer this specific question, I haven't used that. I have only used React Native.
Yeah, okay. Yeah. He also says, I'm going to keep hold of you while I've got it. He also says, have you had any experience of waiting at all for Google improvement to get an urgent fix into the Play Store?
Yes, I haven't personally tried that, but in my previous company where I worked, there we face this sort of issues, like taking time for this sort of approvals and all. But if we are following, if our app is not doing anything, complicated, or if you're following general guidelines, then that should be fine. Otherwise, even if not, then there are options to send an appeal. We can give justification for that, and then generally they approve. But it's always better to follow whatever the guidelines and don't try to bypass certain things. Some of the APIs may be deprecated, or some they tell you not to use. There are always ways to bypass it, but it's better not to bypass, because like I said, Android previously it was not that much strict, but now they are making it more and more strict like iOS. So in future there's a chance of them removing the app from the Play Store if that violates any of their policy. So to be on safer side, it's better to go with whatever they are saying. If they are not approving a particular fix or particular change, it's better to find an alternate way. So even if we are able to bypass them for an year or something, at one point they may remove or take out the app from Play Store.
Yeah. Okay. Thank you. Any other questions?
So you were talking about hybrid apps in the context of simpler problems, and you mentioned booking tickets and stuff like that. And I was wondering if you could talk about, because I would think, because I'm a bit of a dinosaur, I think you write a web app for that. Mm-hmm. So what advantage would I have in writing a hybrid mobile app over just writing a web app which runs in a browser which can run everything?
Yeah, with the mobile apps, the core main thing is the loading time. You don't have to load the entire component because everything is there locally. Okay, with the hybrid and native, okay, we can say that what's the benefit between developing a native app or a hybrid app with the web app, right? So in case of web, and also this offline functionality, let's say we have a local database, we can load all this book information within our local database. I'm pulling the data only once from server, and I can store all this data within my native app locally. Then I can use it, and I only need to refresh it whenever a major update to the books happen. Okay, that's the core benefit of this sort of apps, compared to the web. But for other things, let's say if you have good connectivity, okay, let's say we are in a city, we are targeting audience who generally has good connectivity. Then in that case, it doesn't matter whether to go with the web or mobile app. It's up to us. Okay, but if you want things to be much faster, compared to the web, and even for many of the banks, they are now going with the mobile first approach, because more and more people are using mobile apps compared to the web version of it. I don't know why, maybe due to the speed of this, and also due to the stability of that, because with the web pages, there's it may take time, you move from one page to another, but with the mobile apps, at least the screens appear much faster. Even if the data loading may take time, the screen appears much faster, and you don't have to load all the big images or the text from there, because everything is there locally. You only need to populate the data that you receive from API. And in case of API, it's generally we are using something called JSON format, and this is a lightweight format, JSON format, and then that won't take much time. You can simply pull that data and populate on all the fields which we already defined locally.
So so would you say maybe it reduces your server load because
Yeah,
you've shifted
that's one thing. And also it loads data much faster. Maybe the animation. Okay, if we have, let's say we have an app with a very nice animation, that animation file could stay locally, and the other small data could be pulled from server. Yeah.
In my company, we use, the rule is we go web view as much as we can, so we multi-device, and we use native when there is a differentiating add-on. So the ability to do like VR, the ability to use the device, the gyroscope. If it differentiates the experience and is going to make the app better than the web, then you go native. But then with all those problems, it's much more work. So
that's what I assumed. If you needed sensors or something, then clearly you have to do an app.
and we have to stop our mobile developer to do something just because they can, because the web works as well. So don't do something properly different, then it works it.
And like in case of this GPS tracking, if you want to track your GPS location, or let's say if you want to record a video and upload that video from your app to server, okay, for such things, the mobile apps are much more suitable. And also like connection with these sort of sensors. Let's say we have 10 sensors placed here for maybe for reading temperature or pressure, then the app can communicate with these sensors, and then maybe keep this data locally and store all this data locally, and when net connectivity comes, it can upload all this data to server. Okay, I'm not sure I don't know whether it can be done using web, but even if somehow, then that may take a lot of time, and this offline functionality is the main thing. But many users, many developers generally what they do is that they don't, utilize this offline functionality. Okay, so once we start using this offline functionality, keeping data locally and syncing, then that will kind of unleash the true power of mobile apps.
Any questions?
Yeah. So you mentioned about unit tests and UI tests, and I was wondering, do you do like end-to-end testing in mobile development? So, like coming from web development background, it seems there is a growing interest in end-to-end testing. Like when we do a PR, the CI can deploy the change to a feature environment, and then we run the end-to-end test against the feature environment. I was wondering, do you do the same in mobile development? Like there is a virtual machine running the emulator, and you deploy the change to that emulator and run the end-to-end test?
We generally do that, especially in the company that I'm working. Whenever we push some changes, it's almost same with all the companies. Okay, like whenever we push some changes, everything is run. Like all the tests are being executed and automatically. Okay, in the pipeline. So, for example, in case of GitHub, we have GitHub Actions. We can utilize that. Okay, and in case of GitLab also there is an equivalent, like I think GitLab pipeline or something is there. Okay, in all this we can write code to run all these sort of tests. Whatever we have written locally, then that can happen there also. So we only need to push the changes. All these tests, will happen automatically, and we can even write code to generate a build once the test is completed, and even can write code to inform us. Okay, once that's the entire thing is completed. Okay, so that is working in the same way, like whenever you push a code, or like whenever you merge a PR, this entire process happens, and then make sure that that's working correctly.
So there is a like.
Yes, that's a regular practice with almost all big companies. But let's say you're starting, you're someone beginner or something, then you need not have to do all this. But once, like I said, once you move to the next level, we should do these things, the automation and everything. But if you're interested, we can simply set up, write some small unit test and then add this GitHub Actions. And whenever you merge code or whenever you push an update, you can make it, make all this test run one more round, or every time whenever you push, you can make it run all these things. And then if an error is there, then it will fail, and then you will know that it failed. So that's same, the approach is same.
there's an option in Azure pipelines to be able to test an application against a browser in physical machines. So somewhere in a bunker somewhere in the Azure server rooms, they've got a rack full of loads of different sorts of iPads, and loads of different sorts of iPhones and Android phones, and you can pick maybe one of the targets.
Device
pipeline will magically make it open and give you a feedback, and you'll get a report.
Yes.
Can you do something similar with Google?
Yeah.
With this we can do, but I don't think there is any need to do like that. Generally emulators are fine. Nowadays more and more apps are, more and more devices are almost, like similar. So you can run those tests. I mean the unit test on, locally or within your pipeline. But if you're interested, then yeah, I have heard about such services. I have seen people using that, but personally I haven't used that. But I know that, okay, there are like, such kind of devices are available to you, and you can run it for a certain time, and then you will get a test report and all those things. Or you can run in different kinds of devices. I have seen people doing that, but personally I haven't used. But I feel is that, you only need to write, make sure that it's working properly on emulator, write UA test, and then use this RoboElectric library. That's much faster. It will execute all the UA test, similar to how it executes unit test. It's much faster. So you will get the speed of unit test, but at the same time, it kind of executes, the UA test. Okay, so I think that's enough. And also test in certain devices. If you're developing, you can create different devices on emulator and test. And even with the new Android Studio version, we can turn on talkback. We can turn on dark mode. We can change font size, and we can create different device sizes using the emulator. So we can try all these things basically. Okay, so in that case you don't need. But even in that case, I always suggest to have a high-end device and a device which is not having device with a less powerful hardware. So you can just give it a try and see how it works. Yeah, but it's not, but if you find any service where you will get, where you are able to test in more devices, and if that's not that costly, then there's no problem in going for that. But generally, I don't think that's required, because you can try all these combinations here, and these emulators in Android Studio are becoming more and more powerful. So you can try all this accessibility, font changes, you can create different tablets, different fonts within Android emulator. And then simply write the UA test. And if you can't write UA test, make sure you at least write unit test. So even if we do something different, or if you make a bug, one of the unit tests will break, and the pipeline will break, we will know, okay, what went wrong.
Extreme extension question.
So I'm a Lloyds Bank user myself. So I noticed like a few months ago there is a major design change update, and I was wondering how do you manage that change? How can you deploy the change? Like in native app publishing, you mentioned, is there an ability to like publish a version of application to like 20% of user, or can you do some A/B testing before their full release?
I can't disclose such details with the company, but generally there are let's say you have a feature, okay, you built a new feature within the app. So we can add certain flags, or we can pick certain group of users, and then we can make it only shown to those users, because you have the user IDs with you. Maybe using that, we may be able to show this particular option only to this number of users only. And also Google Play has an option called this beta testers, I think, where you can add certain number of users to your, within your Google Play, you can add certain users in that, and you can publish the latest update or the version of your app only to those users. So the others will not see that. It will only be available on the device, or it will only be get installed on the devices of those users, so that you can ask them to give you feedback. So let's say you have 10 friends, or you hired few people, testers. You can add all their Google IDs into the Google Play, and then you can publish the new update only to their devices. Then they can test it. So like that you can do, and also you can pick few users and then create a group, and then that can be controlled from server. Okay, so let's say when you open an app and you pull the data, okay, and it will let's say you are pulling an API, okay, that API may contain data about enable this feature for this user. So if I'm in that group, that feature may appear on my device, on my app. But if someone is using who is not in that group, that for that person, that option may not appear. That's how generally companies control, such kind of things. Initially they release it to like 5K or 10K users, and then based on their feedback, they remove this restriction and then release it to others. That's a general strategy. But how the company has handled the other thing, first of all, it's a huge team, so I don't have much internal details about that, and also I don't think that's appropriate to discuss. Sorry.
In our company, we're large enough. We use our own colleagues. So every employee of the company who uses the app is registered. So we get a Slack message saying like update coming, and tell us if it's broken before we release it. Nicer feedback this way.
Any questions?
Have you found that having multiple language support has made an effect on the amount of downloads you get or anything like that, or is multi-language kind of a big thing in Android, or not?
That depends on the region where you're targeting. Okay, let's say you're targeting the users in Europe. Okay, in that case you may have to handle like apart from English, you may have to handle Spanish, German, or other languages. Okay, so in that case, we will have to support these languages too. Okay, but let's say we are only targeting UK and US. In that case, English is fine. Okay, so it all depends on your target audience. Okay, if you are targeting people, in different parts of the world where they don't know English, then in that case, yes, we should add support for such languages. But otherwise, if you're only targeting like UK, US, Australia and all, then in that case, you only need English as per my understanding. But if you're targeting Middle East, in that case, the entire thing changes. You need to support Arabic or any other languages. In that case, the Arabic is written from other side, not like English. So in that case, we have to test that properly, make sure our UI will not break when a user whose device language is Arabic installs the app. So in that case, we need to test it. We can emulate all the such scenarios from our emulator. These emulators are just like real devices. So you can go to settings and then make all these changes to the language and then see how it behaves.
An online question says, you mentioned encouraging authentic and positive feedback. Isn't negative feedback also important? I.e., what problems people are having? Is it possible to encourage authentic negative feedback?
Yeah, I think negative feedback, I generally look for negative feedbacks than positive feedbacks, because that's when people are much more honest, when everything goes well, okay, we also think that, okay, nothing is wrong, but with the negative, so generally after publishing an app or an update, I go to Play Store and I go and look for 1 star or 2 star and 3 star, and then try and see what's happening. So that's really important. So it doesn't matter what review or feedback they are giving, we can encourage them to give feedback, and it's up to user, okay? And then try to learn what they are telling, and try to improve our app, and then maybe we improved our app or we fixed that issue, and we can reply as a comment. We can reply to their comment saying that, okay, we fixed this issue, could you please update the latest version and try, okay? Then normally that person, may change the rating from 1 star to 5 star or 4 star, okay? So it's not about whether, whether a review is positive or negative. It's all about, encouraging them to give genuine feedback and try to understand what they're saying, and also make improvements to our code. So, take everything as a learning opportunity and in a way to improve the app. That's it.
There's a crafty way of doing it. You send the request to the customer to go to a link to a Google Sheet, and depending on the rating that they give you in the Google sheet on 1 to 5 or 1 to 10, if they're 7 or above, after they put in the comments and everything, I then point them to the Google Play link for actual feedback. So you always get good feedback on Google Play, but from your Google survey, you get all the negative feedback to be able to do all the bug reports. But you don't, when they do below 7, then you make sure it just stays within you. You never give them a link to the Play Store.
That's one option. One thing what we can do is that maybe during the initial stage we can place a button at somewhere at the top, which is visible to the user, write a review. Okay, so that we can actually capture some of the negative reviews at that stage itself. And then once you have that set of data in hand, then try to fix or make improvements. Then after that only enable this option to prompt them to show the ask them to do the review. Okay, that's what it said. First we need to make sure that our app fixes we fix all the major issues and app is having proper quality, and we address all the major feedbacks. So we first basically take all this negative feedback. Generally, there will be a lot of issues, so we can put a button there, and then if you do that, there are additional benefit also, because once user add data from this sort of feedback within our app, then we can collect a lot of details, like the device, maybe the current status of any errors, or maybe some additional details. So, and we can quickly identify users. Sometimes when users post negative reviews on Play Store, and we try to find out the user using that email ID or name, we may not be able to find that person within our DB. Okay, that generally happens because they use different names or mail IDs. So, but if we have some mechanism within our app, for them to put this sort of reviews, then we will get additional details, much more details of the current status. So before asking them to do the rating, we need to make sure that our app, we solve all the major issues and people are loving it. Otherwise, like I said, it will backfire. Yeah, exactly. So once we reach that particular stage, then we can remove that option within our app or move that to some area like more settings, more section or settings, and then we will not show that big button or kind of that option within the home screen. Then user can directly go and do rating in the Play Store. So it's all about. It's not about There's no one answer to this. It's all about how strategically you are moving, how well you are doing, and it's also more about how committed you are. How you want to maintain this application. So it depends on all these factors.
We've got time for one more question. Is there any burning? Yeah.
Don't know if it's in your remit or not, but how do you actually go about marketing your apps once they're developed?
In bigger companies, that's handled by a totally different team. Okay, we generally do the development, and the testing is done by a different team, and the whole marketing is done by a different team, and the design is provided by a different team. So there are different teams for this. Okay, but in smaller companies, I have seen people doing that they arrange this sort of like meetups, or they put posters, or they use this Facebook or something like that. So or with a different, or sometimes they send some gift, with the company name and with the app link, or ask them to scan and install it, something like that. So that depends on the company, and some bigger companies sometimes send mails, and they may send like SMS. So that all depends on the range and the budget you are ready to put. But generally you only need to post in like Facebook, and it's all about word of mouth. If people love using the app, then the number of downloads will increase. You don't need to do any huge marketing or anything. So it's just like how you market other things. It's nothing specific, but generally small companies or medium-sized companies, what they do is they arrange sort of events, and they inform others that there's an app like this. Okay.
So do you develop apps just for your own company, or are you developing them for other companies and they sort out their own marketing, etc.?
See, in the first two companies that I worked, we used to develop apps for other companies. Yeah. So the good thing about working with such companies was that I could work in different projects. Okay, some of the apps were related to shopping, some were related to survey, like I said, some were related to GPS, some were related to Bluetooth sensors, some were related to map, I mean, I was switching projects. I mean, from like every year, like 6 months, 7 months, 1 year, 2 years, like that. Sometimes once we develop an app, then we only need to maintain. Okay, so once the major phase of the app development is over, we used to hand it over to other developers, or even to their own developers, to the company's own developers. So once the major development is done, we sometimes hand over the entire code and everything, all the data to their own developers, and they handle the rest. Sometimes we continuously maintain all the apps for years, because there are some apps, like some of the companies are maintaining for years, like 10 years, 15 years, like that, okay, maintaining for that long time, because such companies may not have enough developers, or they are not interested in maintaining such a large number of developers or QAs at their end. So the good thing I got that at the beginning of my career, I could work on different apps, different types of apps, and could try different things, different workarounds. So it was a great experience. But right now I'm working for a bank. So where so we are working on a single app now. It's like a lot of developers are working on a single app. So it's like working on different features. So it depends on the company that you are working. If you're working for a service-based company, then you will get chance to work on different apps. But if you are working on any other bigger organization, we generally work on a single app or 2 or 3 variants of the same app.
Thank you very much.
All right, thank you. So if you want to connect, thank you. If you want to connect, here's my LinkedIn QR code. Just send me the connection request. All right. Thank you.